A database is a persistent store of related data. So what does that mean? Persistent means that it sticks around. So when you power off the system and switch it back on again, the data is still there. Related data means all of the information about one thing. So for example, a school may have a database about teachers, students, lessons, classrooms, things like that. A bank might have a database about customers, loans, mortgage rates, anything that they need to operate their business. And the police might have a database about people, suspects or people that have been convicted, vehicles, whether they've been stolen or not stolen, property that's been recovered, that kind of thing. Let's have a look at a real database. So the one I've got here is England Wales Criminal Register, 1791 to 1892. Let's just do a quick search for everybody that appears in this database with the surname Smith. So let me just type Smith in the box and then search. And here they all are. Let me explain some terminology. I have filtered the table down to just the Smiths. So the table is the whole thing, all of the information that we are looking at. So a school might have a table with all of the pupil data in it. It might have another table with all of the teacher data in it. Okay, so this table has all of the people in it. And I filtered by Smith. A field is a single piece of information. We have field names or column names. So name is the title of the field. Estimated birth year is the name of the column or the name of the field. Date of trial is the name of this field. Location of trial. Okay, so these are all columns. A row or a record goes that way and columns go that way. Nelson's column, the statue, goes like that. And if you row a boat, it goes like that across the river. So let's have a look at a row. So a row is a record. A record is, so a row is a record. The record is all of the information about one thing. So in this case, a record is all of the information about William Smith. And that's where the term criminal record comes from. It's all of the information about one particular criminal. Now, was William Smith a criminal or was he acquitted? Let's have a look. He was imprisoned. Naughty, naughty, naughty William Smith. Let's have a look at how we would search a database using structured query language. In your exam, you will need to know a little bit of SQL. SQL is structured query language. Sometimes it's pronounced SQL. You will need to know select, from, and where. Okay, so let's have a look at what I've written here. Select asterisk from customers. So if I just run that, you can see at the bottom, it gives me everything that is in that table. It gives me all of the records. What I've said is select everything from customers. Okay, I could say select city from customers. That will just give me city. If I use asterisk, I can select everything from customers. Customers is the table. You notice I have other tables over here. Categories, that's selecting everything from categories. Employees is another table, that's selecting everything from employees. The products, that's selecting all of the products in the products table. Let's jump back to customers. So select everything from customers. We know how to do that now. We know that we can select customer name, comma, address, comma, city from customers. So instead of just specifying one field or column, we can select more. It would help if I could spell it correctly. Customer, or type it correctly, I should say. Did I get it that time? Yeah. So we've got customer name, address, and city from the table. That's fine, but it's still giving us a whole load of stuff that we might not be particularly interested in here. So why don't we select everybody from customers where city equals Berlin. Look at that, just the one. All right, let's go back. and we've got Mexico. Now watch this, where city equals Mexico. Why didn't that work? The reason why it didn't work is there are no entries in the city field called Mexico exactly. All right, so there's a couple of things about Mexico. You notice I don't have the accent or whatever it's called on the E, and it has to match exactly. It has to match absolutely exactly when you say that. So if I go back to just having a little browse around, it has to be Mexico DF to get a match. Okay, let's just try Mexico with the accent thing, but without the DF, where city is the same as Mexico. None of them there, because none of them are exactly the same as Mexico. So how do we deal with that? We need to do two things. We need to use the term like, and we need to use another wildcard. We've already seen how to use a wildcard when we search for everything from a table using the asterisk. So instead of saying exactly equal to Mexico, because we know it isn't because it contained DF at the end of it, so I'm going to say like Mexico. Okay, still doesn't work, because we haven't given it additional information. I'm going to put a percentage sign here. Now what the percentage sign means is 0 or more characters. Okay, so select customer name, address, city from the table customers, where city is similar to Mexico, then anything else. So it could be Mexico and just that, or it could be Mexico space, or it could be Mexico 999, it could be Mexico, anything after Mexico, or 0 or nothing, just blank. So Mexico anything would appear on my list. Okay, so let's try that with name. So where name is like, let's just go with M. That's not going to work, is it? It's customer name. See how you have to be absolutely spot on with these field names. I've missed the percentage sign off. Now it will work. Okay, so that's found anybody that starts with an M, because we've got M, then anything else. We can find anybody that ends in an I by saying anything, then I at the very end. So anything, then I will look like that. We could probably find it in the middle if we do that as well. So that will give us absolutely anybody that has an I at the beginning, anywhere in between, or the end of their name. I will leave a link in the description for the demo database so you can have a play about with it yourself. In a bit.